Hello everyone, I welcome you all to my YouTube channel. In this lecture, we will start solving for the protection angle method, and we will start from where we had stopped in the last lecture, in the previous one. So we were discussing about different protection angles and where it is valid and where not. Now we will do some examples. So let us start with understanding more about a protection angle. Suppose this is your rod. So the protection it offers, if you see this rod, it is in a conical form. It is not only in one way or on the left side or right side, it is in a form of a cone. So all this area which is covered now within this cone is protected. So any equipment within this cone is protected, and you know how to find the alpha in order to make this cone. Normally we don't make this cone, we make a 2D figure only. So this angle alpha we can calculate or we can check from this figure which we have seen for the protection angle based on IEC 62305-3. So it has different values for different classes, class 1, 2, 3 and 4. So suppose for class 1 you are going for 10 meters, it will be 45 degrees as we have seen. For class 2 it will be 54. And if the rod length is 10 meter and class 3 it will be around 61. Similarly for class 4 it will be different. And these are the limitations. After 60 meters you cannot use this method, you have to go for rolling sphere. In case of class 3 after 45 meters you have to go for rolling. In case of class 2 you have to go for rolling after 30 meters. Similarly 20 meters for class 1. Now you have this angle. There is an equipment here, it is protected. If there is some part of the equipment which is lying outside, that means this area is unprotected. So what you can do, you can either increase the height, but then the angle will also change. Be careful that by increasing height, it is not that the angle will remain same. The angle will be different in that case. It can be somewhere like this. It can protect or cannot protect. It will be alpha 1, alpha 1. Or there can be, you can shift the equipment inside, or you can provide some air termination rod here on all the 4 sides or only on the 2 sides. That you have to decide, which we will see how to do. Now let us take an example, a simple example in order to understand this method. Now first thing we will do is a mistake in solving this, and then we will understand the correct part. So this is your A terminal rod in red color. It is on the edge. Let us suppose this is 3 meter long rod and this is 7 meter. All the dimensions are in meter. Then there is another rod here on the other side. On all the 4 sides there is rods, and again it is of 3 meter. This is 7. There is an equipment in between. You can say it is 2 meters from here and 2 meters from here, and equipment is, let us suppose, 1 meter. And then there is an equipment here below which is again 2 meters away from the wall and 1 meter, you can say it is long, or width is 1 meter and the height is, let us suppose, 2 meter or 5 meters. Now we need to check whether this rod will be able to protect this below equipment E1. This is E2. So whether equipment E1 is being protected or not by this rod. Now in order to check the protective angle from the graph, you need to know that what is your reference plane. So in case of this, how you decide the reference plane? Based on which equipment you are being protecting. So here we are protecting E1 now, we are talking about E1. So the reference flame is this, which I have highlighted in bold in the black. So from here you see where is the rod? Up. Rod length is 3 meter, but the total length of the rod from the ground surface is 3 plus 7, that is 10 meter. So you have to do for 10 meter. You have to go and check the angle for 10 meter, not for 3 meter. Please note this. So now for 10 meter, and we will assume everything class 2 here. Everything will be for class 2. All the examples in this lecture and the next lecture is for class 2. This is just I am taking for my convenience. Now For 10 meter, this is the angle. If you see, this is 54 degree. We go back and we try to make a line 54 degree. Now this line can cut also, we don't know. So this is what we have to evaluate. Now let us suppose this is the triangle. This is A, this is B, and this is C. So I will make a triangle below. A, B, and C, and we know this angle is 54 degree. This is 10. We don't know this length BC, so we can find it by using trigonometry. Tan theta is equal to perpendicular upon base. So this is your theta and this is your perpendicular and this is your base. So here in this case, this triangle is shifted. So this has become your theta, 54 degree is your theta. So this is your base, which is 10, and this is your perpendicular. So we know that perpendicular we have to find, base is 10. So tan of 54 degree, we check on the calculator, we get the value 1.376. So P is equal to 13.76. So we now know that this complete length is 13.76 meters. Now this equipment is 2 meters away. So we shall check, okay, what is the height at 2 meters? No. What we shall do is we shall check on the worst case, that is this point. If you see, there is enough protection here. There is enough protection here because this is more near to the wall, more near to the lightning rod. As this point is far away from the lightning rod, so it will have a very less amount of protection. Here there is more. So always you take the worst case for solving. So we will check this edge only. So this edge is how much away? 3 meters away from B. So we know something 3 meters away. We know that the height is 5 meters, but let us check what is this point. If you get to know that this point is more than 5 meters, that means your height of the object is within this. So now we have to evaluate this point. So let us make a line here, join these 2 points, a straight line at 90 degree. So these 2 lines are parallel to each other, this line and this line are parallel. So that means angle this is equal to angle this, corresponding angles. Now this is 3 meter, so this will become 10.76. Now in this new triangle, let us suppose it is D, E and C. D, E and C. We know this is 54 degree, we know this is 10.76. So we can find this height. So this height will be 10.76 divided by height equal to tan of 54, which you have already got, that is 1.376. So h is equal to 10.76 divided by 1.376, which is nothing but 7.8. So this height comes out to be 7.8. Your equipment length was only 5 meter, that means you are successful, you don't need to provide any additional protection. If your height of the equipment would have been 8 meter, there would have been problem because this part would not be protected in that case, the one covered in red. In case it would be 8 meters. But now it is 5 meters, no need to worry. Now let us check about the equipment on the top, E2. Now this part is correct, there was no mistake in it. Now we will make a mistake while solving for E2. Now this is your reference plane, be careful. Earlier reference plane was below, now the reference plane is here because equipment is here. So we will check the height of the rod from this reference plane or height of the air termination. It is 3 meters, only the length of the rod. So we will not use 54 as the angle, now the angle will change. We will go back to the standard, we will see, okay, for 3 meters that means something around here. For class 2 it is providing this protection, that is the angle is 70 degree. I am sorry for this, the angle is 70 degree. If you see here, Then we will go back. We will go back and make an angle here, and we don't know whether it will touch or whether it will pass over it. So this we will evaluate now. So let us evaluate like similar way. We know the triangle, we know this is 3, this angle is 70 degree. So see, here it was 54, here it is 70. So this cone of protection can have alpha as well as beta based on the reference. So if the reference was here, if this is the reference, so it can have alpha here but beta here, a different angle. Now we know it is 70 degree. This is 3, so we will calculate this. How? Basic trigonometry, tan 70 is equal to, this is your perpendicular upon 3. Tan 70 is 2.747. So perpendicular will come out to be 8.241. That is 3 times 2.747. Now again checking the worst part. The worst part is this line, which is far away from this rod. So it is 2 plus 1, that is 3 meters away. So from 3 meters away from this point we will check. So this is 3. So this remaining part is 5.241. This angle is 70 degree. So for 5.241, the protection is, this is your base. So 5.241 by base is equal to tan of 70, which we know is 2.747. So we will get the value of base, which will be equal to 1.9. So if your equipment length is 1.9 meters or 1.8, you are saved. So let us suppose this is 1.8 meter in height. There is no issue, because on the roof there are many HVAC equipments or other equipments which you install, which also have to be protected, which also have to be calculated, because sometimes it happens that you are saving your structure. You save that, okay, my structure is protected everywhere, there can be no damage, low lighting strike on the wall, nothing can happen here. But you have to also evaluate what will happen on the top. So you provide 3 meter, but equipment is 10 meter or 5 meter long. That means you are doing a mistake. You need to check also for the equipments on the top, which you are doing now. So now you are doing it, you find it is 1.9 meters, equipment length was 1.8, it is protected. But what mistake we have done? We have done a wrong calculation, not in trigonometric terms. This all what we did was wrong, not for this one, I am sorry, for the previous one. Only for this top it is wrong. Why? Because we are only seeing the section of the wall on this side. We have to see the plan view. Generally we tend to make these mistakes. We are only seeing the sides. So this is the 4 rods which are there. If you see from the top view, the equipment is not thin and just placed here. The equipment will be placed somewhere in between, or it can be placed somewhere here. So you have to check the diagonal length, not this length. So in this case, let us suppose it is in the midpoint. So let us suppose we wrote here 2 meters and this also 2 meters. Now let us suppose this is 2.5 meters away. Although I am just making a mistake, I am just giving you a calculation. We were doing here and this was 1 meter long. But let us suppose due to, if you do the analysis, this is 5 meters. So this length is, let us suppose, 3 meters away, which is not correct. Just giving you an example. Don't try to apply Pythagoras theorem and just check exactly. Let us suppose it is 3 meters and this is also 3 meters, just for simplification. This was 1 meter, this was 1, this was 1, so this will become 1.414. Okay. Now you have to check for this section and not this section. So this section is wrong. you have to check for this section, section AA, not section BB. So in case of checking for this section, we will now plot. Let us suppose this is 3 meter long, this is 3 meter long, and equipment is in between, 3 meters away, 1.414, and again 3 meters away. Now again the angle will be 70 because this is your reference frame. So we have to check whether it will cut or not. So obviously it will cut, but we will check now. So let us suppose this is our triangle. We know this is 70 degrees, this is 3, this is 8.241 from the previous. But now we have to check at a distance of 3 plus 1.414, which is around 4.414 from this point. So now subtracting 8.241 from 4.414, it will come out to be 3.827. This angle is 70. You can find this value, that is 3.827 divided by 2.747 in order to calculate the base. So 3.827 divided by base is equal to tan of 70, which we know is 2.747. So we get the base value as 1.39. So you see, previously you were saying my equipment is protected because we were getting 1.9 meters and the equipment height was, let us suppose, 1.5 meter. I would change the previous height of the equipment and make it 1.5 meters. So we were able to say that okay, this equipment is 1.5 meters high and it was protected because the protection provided was this. But now when you actually solved based on this cross section AA, you found that no, we were wrong, it is 1.5. The protection offered is only 1.39, so it is not protected. There will be some edge which will be exposed. So this is your equipment, so this part will be exposed and there can be a lightning strike. So now in this case you again have to do the calculation. Again there is a 3 meter rod here and we can check that it will be protected because it will also provide some protection here. But in all, the overall protection provided by both these rods will be this pink region. I will just shade it. So the equipment is within this pink region. Yes, my equipment and all the edges are between this pink region, so there is no issue. What you can do in order to evaluate, you can check the midpoint. Just giving you an example. So in this case, for doing midpoint, this will be 3 meters away. This is 3 meter away and midpoint of this is 0.707. So this distance will become now 3.707. Whole length was 8.241. So subtracting these two, 8.241 minus 3.707 will give you 4.534. This is 70 degrees, so you will get this value as 4.74 divided by tan 70, which is 1.65. So now you see it is 1.65. So in the midpoint is within this. So it is within this protection part. There is no issue because this height is 1.5 meter and this part is 1.6. So this was your equipment, which is maximum 1.5. So similarly this rod will also protect it. So in this case you have solved that okay, my equipment is protected. In case what I wrote, these dimensions are not correct, this is just for example which I gave. In case these dimensions are different, if you actually make their dimensions, you find that they are completely different, and you find there is an issue here. So what you can do, you can not only increase the length of the rod, you can avoid increasing the length, you can place these rods on the parapet. So this is your structure, there will be a parapet wall here, you can place these rods on the top. This will help you increase the height by depending on the height of your parapet. It can be 1 meter, 1.2 meter, whatever. Moreover, if that is also not available, if it is a railing or something and you cannot place, then you can provide a concrete block on which you can increase the height, a foundation, small foundation for this rod, and which can increase the height of the complete rod. So without buying extra rod, this rod you are not purchasing, this is still 3 meter, but by providing this 0.5 meters of foundation, you are able to make it act as 3.5 meters for any equipment on the top. So this is how you solve for protection angle. I hope you understood what common mistakes we make and how to solve it, and this is your graph which you have to use it. Thank you for listening, and God bless.